In this first question, we have one sample of 50 laboratory blood tests. And this is a question about a mean. So this is a hypothesis test because we are looking for evidence. So this is a t-test. So in this next question, again, we have one random sample of 49 records. But this time, we're not interested in doing a test. We're trying to estimate what the real population parameter is. We're trying to create an estimate for the average number of hours that LA doctors work in a week. So again, this is a question about an average or a mean. So this is not a test. Instead, this is a t-interval. It would be perfectly fine to call this a one sample t-test or a one sample t-interval, but it's clear that it's only one sample and t is for means. So in question number 3, notice this time there are two samples. We have a random sample from 1975. We have a second independent random sample from 1991, and these are questions about proportions. So I know it's about a proportion because specifically it says proportions right here. We're given the counts, but we could turn those into proportions. So this is a two sample situation involving proportions. And again, I'm interested in evidence. So evidence of a decrease in this proportion. So this is a two proportion z-test. Again, z's for proportions, t's for means. This question here is clearly about a linear relationship because that's exactly what it says. We have quantitative data, we have explanatory or x values and y values. Those are the response values. So here we are interested in, again, in evidence of a linear relationship. So you could write this hypothesis in words. There is no linear relationship between the percentage of 16 to 9-year-olds not in school and the death rate versus there is a linear relationship between the percentage of 16 to 19-year-olds not in school and the death rate. However, you could also just frame this in terms of slope. The null hypothesis could be that the slope is 0. The alternative hypothesis could simply be that the slope is not equal to 0. So either way, this is a t-test for slope. Number 5. So again, this is about proportions. This is a one sample situation because we're looking at a sample of 2,000 kernels of popcorn. But again, we're not looking for evidence of an alternative hypothesis. We're trying to estimate the actual proportion of popcorn kernels from this manufacturer that fail to pop. So this is a one sample situation. It's about proportions, and I want to make an interval. So this is a one proportion z-interval. Question number 6. So here we have paired data. So we have the same 6 salespeople, and we are looking at their sales with a bonus and then their sales subsequently without a bonus. So if you look at this, we are interested in evidence. So we are interested in doing a hypothesis test that sales dropped when the bonus system was discontinued. So what we're really interested in is the difference. We're really interested in the difference between their sales with the bonus and without the bonus. So we're expecting a drop here. That's what we're looking for. So again, this is something that we could not phrase in terms of a proportion. This is something we would have to phrase in terms of a mean, in terms of a t-test, and this is paired data. There are not two samples here. We have one random sample and two observations, or a pair of observations for each person in the sample. So this is a matched pairs t-test. Question number 7. Again, this time we have two samples. We have 43 dogs using program A, 41 dogs using program B. This is a question about means because we're looking at the average number of training hours, and we're looking for a difference between the average number of training hours for these two programs. So this is about averages. We are interested in evidence, so we're going to do a test here. So this is a 2-sample t-test. Question number 8, this is categorical data instead of quantitative data. The two categories are with and without music, and categories in terms of the number of books that are sold. So understand, first of all, it's categorical data, so that's a good clue we're likely to use here a chi-squared test, and this clinches it. We're interested in evidence of an association between Christmas music and book sales. So this is a chi-squared test for association or for independence. It doesn't matter which word you use. You can use the word association because that's what's used in the question itself, or you could also use the word independence. Question number 9. So this is an interesting question because there's really only one sample, 128 out of a random sample of 317. So we only have one random sample here. This 39% is the percentage that we would use in order to build our null hypothesis. We're interested in evidence of an attitude change, and this is an attitude change that we're characterizing in terms of percentages. So this is a 1 proportion z-test. Question number 10. So again, we have paired data. It looks like we have 2 samples. We do not. So this is 1 sample of 8 adults where we have 2 observations for each person. Their time in seconds to run a mile using regular shoes and using new shoes. So this is a matched pairs test. And more importantly, it's about means. So this is a t-test because we're interested in the average decrease in running time, how much the running time has dropped wearing regular shoes to wearing the new shoes. And we're not doing a test. We're trying to estimate what that average decrease is. So what this really is a matched pairs situation. We're using means, so it's a t situation, but this is an interval where we want to try to capture what that real population average decrease in running time might be. Question number 11. So we're looking for evidence. So this is a test. So this is a test about a mean because we're interested in testing this claim. We're trying to find evidence that the manufacturer is making a false claim, and their claim is about a mean. Their claim is that the average price for this vehicle is $16,000, and all we have is 1 sample of 50 recent purchasers. So this is about a mean, so it's t's, and it's a 1 sample situation, sample of size 50. This is a t-test. Question number 12. This is a chi-squared goodness of fit test, and the reason being we have counts of peanuts and almonds and cashews, but we could turn those counts also into percentages. I can see what percentage of this sample involved peanuts or almonds or cashews, but I can't do a 3 proportion test. So what I have to do is a chi-squared goodness of fit test here because I have a model to follow. We believe that according to this company, their mixed nuts are packaged. Half of the nuts in the standard mix will be peanuts, and the other half will be divided evenly, 25% and 25% between almonds and cashews. So I have a model to follow, and I can see if the actual counts we've observed match the expected counts claimed by this model. So this is a chi-squared goodness of fit test. Question number 13. This is a 2 sample situation. So I have a sample from Park A. I have a sample from Park B. These are peak wind gusts that come from different weather stations. So this is not paired data because they're coming from different parks. So this is, again, a question about a mean because I am interested in the difference in the peak wind gust speed. So that's not something I could express in terms of a proportion. That's something I would have to express in terms of a mean. So I have two samples here from two places. I am trying to do an estimate. So in that case, I'm interested in doing a confidence interval. So what this is a two-sample t-interval. And what we're going to look for is the difference between the mean peak wind gusts in these two parks. The last question here, this looks like it is a chi-squared test, but it can't be done as a chi-squared test because of the direction. So recognize I have categories. I have pain reliever A, I have pain reliever B, and is it effective or not, yes or no. So I have categories, but be careful, I can also create percentages here. I have a total of 500 subjects that used pain reliever A, 221 said that it was effective. I have 500 subjects that used pain reliever B, 198 said it was effective, but I can't just do an association between the pain reliever they use and whether or not it was effective, because I'm interested in deciding if pain reliever A is more effective. A chi-squared test for association for independence doesn't let us test a direction. So we have to think of this in terms of a two-proportion z-test. So I have random assignment to two treatments, treatment A and treatment B. And I have those two proportions then that I want to compare. This is a two-proportion z-test.